Today we are going to study VI characteristic of diode. VI characteristic VI characteristic of a junction diode. VI characteristic of a junction diode. We have already learned about the junction diode and its functions, how it works. The charge carriers in junction diode is your electrons as well as holes. When we say VI characteristic, it means that how current varies with the variation of voltage. How current varies with the variation of voltage. We have to check how current varies with the variation of voltage. For this, first we draw the circuit arrangement for this. Circuit arrangement for this is as we take a PN junction diode. This is our PN junction diode, right? And we know that this is your P and this is your N of PN junction diode. And this diode is connected with a battery and this battery here we are using with the help of rheostat. Here we connect a milliammeter. We take a switch. This is your switch. And we connect a voltmeter to measure the potential difference between P and PN junction. This arrangement is our arrangement of diode under forward biased. Why? It is forward biased because the p-type of diode, p-type is connected with positive pole of the battery, and here N is connected to the negative. This is the symbol of variation. So we are here with the help of a variable resistor, that is your rheostat. With the help of rheostat, that is your variable resistor, we can vary the voltage or potential drop across this battery. This is the circuit arrangement of forward biased to study VI characteristic. Now we we will see how the current varies. When we start with the very low voltage here battery, then the current flows in the circuit in this like this. Current flows the circuit like this, and this like this. Current I, and with the help of uh, here V, with the help of voltmeter, voltmeter is always connected in parallel and ammeter is always connected in series. So here we have connected this ammeter, milliammeter, in series to measure the current, and a voltmeter to measure the voltage. So here with the help of this voltmeter and ammeter, we will have the values of current for different values of voltage. Now how varies? This is the circuit arrangement. When we increase the value of this battery, voltage of this battery, we get a current in forward bias. But initially we don't get any current. Why? It's if we draw its graph, then it will be like this. It will be like this. This is your voltage axis, and this is your current axis. We get, if you draw graph, we get like this. If you draw a graph, we get a graph like this. Now here, where it rises, we get 0.7. This is your 0.6. This is your 0.4, this is your 0.2, and here it is origin. This VI characteristic is for silicon diode, and for silicon diode the threshold voltage is 0.7 volt. That's why we see exponential rise in the graph at 0.7 volt. Here you will get 0.8 and here 1. Likewise, here we get current in milliampere. It's 20, it's 40, it's 60, and like this. And here 100 milliampere. This is measured in milliampere because in forward we get greater current with respect to the reverse bias. So in forward we measure the current in milliampere, and this is in volt. So we get a VI characteristic like this. Why is this graph like this? This graph is like this because here we see here in the forward bias, when we keep this voltage very less, we start with 0. When we make this like this 0.2 volt, we take the voltage 0.2. For this voltage we don't get any current. Here you can see the graph, we don't get any current. The current is almost negligible. Why is this? Because we know that we have a potential barrier threshold voltage. Due to threshold voltage due to threshold voltage we don't get any current. Now what is this threshold voltage? This is for silicon, it is 0.7 volt. So we will not get any significant current in forward bias unless otherwise we reach the 0.7 volt potential here. Now why? Because this threshold voltage is that we have a potential barrier. I had already taught in the last class and the previous classes that when a PN junction is connected, a potential barrier is created due to the diffusion of majority carriers. For example, this is your p-type and this is your n-type. Then here we have holes, majority of holes and minority of electrons. Here we have majority of electrons and minority of holes. Holes get diffused in n-type, and that's why it becomes negatively charged. So this space region becomes negatively and this becomes positively charged. Due to this, here a fictitious battery is created. So p-types become negative charge and the n-type becomes positive charge, and that's why it behaves like a battery which is precious. Actually there is no battery, but it behaves like this. That's why we represent it as a battery, because it is negatively charged and this region becomes positively charged. Due to this, potential barrier is created, and under equilibrium condition there is no flow of current. We have studied in p-n junction formation. So this when we connect it in forward bias, then this biasing is opposed by this, and for silicon this is 0.7 volt, so its polarity is just opposite. When we connect the battery, we will not get any current unless otherwise we cross this 0.7 volt, because this battery, Fixier's battery, works in opposite direction uh, with respect to the forward bias. That's why we don't get any value of current in forward bias unless otherwise we cross the 0.7 value, this 0.7 volt for this. That's why in the diagram, in the graph, we don't get any value in forward bias unless otherwise we cross this 0.7 volt. After this, what happens? Even with a slight increase of potential here voltage, battery voltage, we get a large amount of current. That's why the graph increases exponentially like this. So this is the VI characteristic of the forward biased. So when we connect the diode in forward bias, we get value of current like this. We don't get any current till it reaches the threshold voltage. This is your threshold voltage, and after that the current increases exponentially. We say it forward bias. So this was our forward biased circuit arrangement and VI characteristic for silicon diode.